Hello, Paulo here. Today I will talk about making our own differential and especially how the steps I made on my journey to make my finalized differential here, as you can see. First of all, of course, I'm not a fusion specialist. Um, I I do my best to make my drawings, but of course, there's a plenty of ways to make better drawings than mine. But my goal here is to share my experience so you can see how easy it is to make some complex parts with fusion. First of all, I will start showing my first version of my differential, which is this big guy here. Um, Inside you can see the gears. Let me just rotate a little bit, and you can see spiders and side gears rotating as I turn it. And of course we can rotate the shaft, and you can see the entire piece inside the rolling, which is amazing. This was my first version because it was more easy to make a bigger part like this, and then I decided to try to make a small version of it. So I did a version with the half of the size, which is this one. I'm really proud about this version because it's small, it's more simple it was more simple to draw, of course, because I had a lot of experience for the previous one. Um, and it's flexible, so it's easy to change it, it's easy to modify as you need. Um, let's see this working first. So as you can see, we can first turn it on this. Okay, here I can show it. We can just turn the main shaft, and the two lateral shafts will turn on this direction. If I froze the main shaft and turn this one shaft, the another one will turn all the way around. And of course, if I just turn the shaft, this this main one will turn again. This little part was amazing to do, and of course, it was more easy than the whole differential, but it was amazing. And that's it. So let's break it apart to show each piece. These ones are just simple shafts which you can put here and easily remove them. Uh, the goal is just to transfer the torque between this gear and anything you want here. You can just put a rod or make another stuff as I will on this version. Here we have the lateral connection, which will be used to the main shaft that will hold everything. And if I open it, let's just open, we can see the holder of the bearing, and here the internal structure. I will need to make a little bit of first remove it. Okay, just remove it. And okay, this is the whole case. We can see a gear inside of it. Let me, yeah, the main pinion. And here, let me connect again the lateral shafts. It's really interesting to see this working. So as I turn one side, the other side will turn all the way around. I tried my best to use simple pieces, like using the same bearings inside and outside. Uh, on this one, I used only one model, one size of bearing. On this one, I used two sizes because this one is smaller. So we have two, one inside, another outside. And here, the four bearing are the same. So yeah, it's easy. I can just remove it. This is the entire piece, internal piece. So yeah, now it's easy to connect, easy to modify as well, as I will show to you. Okay, so I will show now I will show the fusion, how I did this differential. Of course, I will not show step by step, like drawing the everything, because it will take like 4 hours of a video probably. But I did a video showing how to do the, on my view, this more complex part, which is this bevel gears here inside of it, and this one connected to this another one. So all of those gears are bevel gears, and I did two tutorials, one complete with about 1 hour showing each step and why, and another one with just 20 minutes showing quickly how to do it. So you can check the links on the video description to see how to do yourself. The good news about doing your own bevel gears is that what you learn doing it could be applied to anything. For instance, just by doing that first tutorial, you can make it the entire piece, the entire differential with that knowledge, which is incredible. So let's get to the fusion. Okay, I will start showing the first part of fusion, which is the first part I did when I started making this smaller differential. Why this is the first part? Because I wanted to be the smallest as possible, and the smallest gear I found viable on 3D printing, a normal 3D printer like this, is a gear with 8 teeth. So this one has this both all of those gears actually has 8 teeth. These lateral ones, those lateral ones are easy. We just have a hole here, and the top and bottom ones have this connection with the axis. So this is interesting because you just plug in it and you receive the whole force of the gear on this axis, this shaft action. So yeah, this is the first thing I did. Right after making this, I wanted to make this bigger one with the smallest size possible, because this bigger one decides defines the whole body of your differential, the whole structure around. So I try to my best to do the smaller possible, small size as possible, and the knowledge to make this is the same of making these bevel gears, which I just said that I did an entire video about, 2 entire videos about it. Okay, so making this, we create another fusion design, and one interesting thing about fusion, you can import designs between designs. So I can create a new design and import anything I want around it. On this case, if I just need to click on this, insert into current design. So I will import this spide, my side gear, inside of my drive, pinion, and ring gears. So if I show here, I can show you the inside gears, and I use them as a reference for everything, because first of all, with this size in mind, I created this bottom gear, and of course this lateral pinion, and the whole structure here was created based on the distance between this gear, ring gear, and this one. So everything is based was based on related on this gear. So as you can see on sketches, let's get inside of sketch. This is the base gear. Yeah, this is the main structure. Let's edit it. Okay, now you can see I basically what I did was importing these main gears inside of it, and I projected this line and this line. So, and of course the bottom ones too. Here I can remove, yeah, this is better. So I started by projecting it and creating the whole sketch around it, because once you project, you have the exact position of each line you are projecting. This strategy was great, and it was easy to make everything around it, because what you just need to do is project the reference, the points that you want, and draw everything around. For instance, this is the chamber of the bearing, and this is another chamber of another bearing, and those are connections, because on 3D printing we need to it's not good to have like a straight line, we need to have some angle to allow our printer to make the whole printing without needing to make bases on our print, which is good. So yeah, and of course I create this lateral drawing which connect those two parts, and this is the most important part because basically what this does is create the entire structure, because I will use Revolute tool to make this whole structure around, which is interesting. And here I made the connection. So this let's get this part, this whole structure here is a separate part, which is this one, which I can disconnect and connect again. So this part which I just selected is this, let's upside down, yeah, this part here. So I can disconnect and put the gears inside and connect and use and connect these two parts together, which is incredible. Okay, so once I finish this sketch, I can, let's show the case. I have a lot of bodies here, but yeah, the case is connected to the bottom gear, which is this one. Here, let's just connect, yeah. And of course, yeah, yeah, this is the case, the body 2022. So this is the case which was made by using revolve tool inside of that sketch that we just saw. Let me show it again, yeah. And after it we made the revolution around it, and I split the piece with three parts and removed the lateral parts. That's why I can see through it. So of course this entire project will be available for download on the video description, and you can see everything I did on this timeline, which is incredible. This timeline is perfect. For instance, this is the one revolution. Let me get the another revolve. Yeah, this is another one, which is for the button, and yeah, this is the one I just talked. So yeah, as you can see, the revolution itself, the revolve, to create the whole circle around. I can edit if I wanted. For instance, I can remove parts of it, which is not the case right now. But just for showing, you can understand by seeing this timeline, you can edit everything, which is incredible, and see the source code, let's say, of this entire part. Okay, after doing this, the next step was to make the entire case. I call it the external case, which was a part using these ring gears that I just showed to you. So I imported this on a new drawing, and again I use it. Let's show on this angle. Okay, as you can see on purple, those are projections that I did from the previous design. Like this one is a projection, this another one is a projection, and I use those projections to make my external drawing, which will be the case, this case around everything. And yeah, that was really interesting. And again, I used the same concept, just making a sketch by using the reference points that I took from projections, and make it revolve around something, and then making some adjustments. So let's show some adjustments here. The main sketch is this one. Let's edit it. Again, we have a lot of information about the distance between each part. Here is a part for helping 3D printing, because this part will be printed on this side, and this helps our 3D printer to make a good printing. So these small details are important when you are printing. You need some angle to print parts, to make connection between some parts when the printer is closing, you can't just make a straight angle because it won't print well. um, okay, without support, of course. That's the whole goal here, is avoiding using support on 3D printing. Okay, this is one sketch. Another one will be related to make the external part, which is let me show to you. Okay, which is this part here, as we can see. The second sketch is related to make this whole part, which I extrude to allow the main pinion to connect on this differential. And of course we have a lot of other sketches. For instance, this one makes the connection. We need a way to put all the gears inside and easily remove them. So it's not the most beautiful way, but I like it because it's easy to use. I can easy put some screws here, and it's work great. So I remove and put again, and easily can fit everything together. So yeah, it was this part, and the last sketches are related to the hole to make it available. For instance, this hole here to make the external connection, and the holes for the future connection, which will be the future part of this entire piece. Uh, it's flexible. The good part about using Fusion is you can, of course, other software has this too, but I just know Fusion. You can easily change everything you do. For instance, let's say you want to print this differential, but you don't want this front part here because on your project you don't need it. On my case, I need, because my differential will make this movement. So I need a way to grab it from here and from here, and it needs to turn. So that's the why I did these two supports here and here, when I will have something grabbing those and allowing the differential to turn. But let's say you don't need this. So you just need to remove this part, because the other one, of course, you can't. Otherwise, you cannot have the connection. But let's remove this one. So the only thing you need to find on this drawing is how Paulo did that. How do I did that? So you can, of course, I just look at it. I know this is the extrusion responsible for it, but you could search on any extrusion like this, and so on, and you can see those extrusions are related to the front part. These are varied shafts. Okay, this one is holes, and this is the lateral part that I want to remove, and of course this one too. So I can just suppress features here, and this one I don't know, this one I don't know, but this one I want to suppress as well. Nice. So as you can see, I suppressed this one, and those are connected to it, so they are suppressed too. I could just let's unsuppress again. If I just did do this, suppressing this one, it will suppress everything related to it that need it to work. So Fusion is amazing. It's so easy to make the thing. So now you have a differential without the front pinion, so it could be better for your project. You can increase the holes easily too, because these are made on sketchings, so you can see the sketches as they are mirrored. If I change this one, the another one will change as well. The same applies here. So yeah, it's easy. They are not connected right here, but you can connect. But it's easy if you change the size. Let's say change the size of the hole here for, let's say 3.8. Let's put like 5 millimeters and apply it, and you have new holes with 5 millimeters. That's amazing, because you can easily change any part of your project and just apply it, and Fusion make the new extrusions for you, and you can just export the part and print it again. So it's really easy to modify. Let's undo my changes here, and it's really easy to modify and reuse your part as you need. So yep, that's it. Um, that's it. My main tutorial. Let's get the hop out part. So I hope this entire video showed to you how easy it is to use Fusion, and most important, how you can split a project, a big project like this entire differential, in small parts inside of Fusion, and connect those parts using a reference from one part to make another one. Fusion allows you to make amazing things, and for me was like I felt in love with Fusion when I first on my first uses, and each time I use it, I love it more. So Fusion is for me a great tool, and it allowed me to make without that much knowledge. It allowed me to make these complex parts that, and now I can make my own projects and have my ideas on my mind being made on physical products or physical parts, which is incredible for me. So thanks for your time, and if you are like this video, please share and comment. Bye.